First thing I want to talk about was the thing last week with the spell checker. And like I was saying, it wasn't done quite right, the linear spell check. And let me just show you the difference here. Okay, so this is the version they had. And whereas this is the version, the way I fixed it. And my point is, it should have just counted in both cases. What they try to do is get away without making a new variable. And it kind of worked. First of all, look at this. Here's the dictionary. Give it a second. The first word in the dictionary is A, the word A, yes? So, come on. Wait, hold on. Okay. So my question is, if I ran their method and I looked for the word A, which is the first word in the dictionary, what would it return? It would say number of words checked. It would find it, and then what would it? You know, right here. It would say number of words checked, and what would it say? How many words? Anybody?
One.
Should have been one, but actually it wouldn't be one. It would be 0.
Yeah.
Because I starts as 0, right?
Mm-hmm.
And by the way, just for the record, this text file all gets read in and stored in a huge array list, right? Dictionary is my array list, and you know the first word in the file is a spot 0 in the array list. The second word is a spot 1 in the array list, and so forth. So I'm saying their code was flawed for 2 reasons. One is it's off by 1. Like I said, it would if you look for the first word, it says it searched 0 words when it should have been 1. If the second word is it would say search 1 word when it's really 2, and so forth. The other thing is right here, they put size when it will look with the linear search. You search for the whole thing, and if it's not there, you'll have to search every word. So this is not the wrong answer, but it wasn't necessary to put dictionary at size. Look at this code down here. I made a new variable to store the count every time I incremented, and I mean every time whether I found the word or not. And then this part's the same basically, except for it's accurate. It would if it found it first time after the first word, it would return 1, and the second word would return 2. So but more importantly, right here, I put the variable count, and like I said, these 2 methods return the same answer if it's not there, except this one just they hard coded it, whereas this one it actually will count the whole thing, and it'll be the size of the dictionary. Okay, and the reason that's important is because when you try to make binary spell check count, you need to be doing it like this, where you make a new variable that starts at 0, and no matter what, you're outputting count. You're never doing size. With binary search, it's never actually going to equal the size. That's the advantage. See what I'm saying? You put count here and you put count here, and that's how it should be in both cases. The difference is here, every step of the way, you find the middle. With binary search, you look in the middle, and by the way, one quick question. Before you can do binary spell check, what has to be true about your list for this to work?
It has to be sorted.
Yes, good. And so it's much faster, assuming you have a sorted array or array list.
Mm-hmm.
Anyway, once again, every step of the way, you get rid of half the contents. You eliminate half the list. And so it's based on logarithms. And so if you have 1,000 elements, let's say you have 1,024, which is to the power 10. Then basically after around 10 steps, you'll have either found what you're looking for or you'll know it's not there. And think about what I just said. For 1,000 elements that are taking around 10 steps, with linear search, how many steps would it have taken at the most? 1,000 steps, yes?
Mm-hmm.
And so if you do 1,000,000, 1,000,000 is roughly 2 to the power 20. Binary search will find it or know it's not there after 20 steps, whereas linear search will take 1,000,000 steps. And so that's what I'm trying to say, is up here, this code will return the size in that case where it's not found, but they shouldn't have done it this way because that's only true for linear search. It's not true for binary search. Okay? Any other questions about that? I do want to mention, like this week, almost everyone got the table turned in correctly, and so it's the same idea except for it's now for sorts. That's for the future. Like you had 3 parts of the assignment this week. One is to do the string formatter that I'm about to talk about. Another one is to do the climbing club, which I've halfway got fixed. I should have it up and running by tomorrow. And then the third thing was section 7.6. And so what I was about to say is section 7.6, you're basically doing the same thing that we did for searches, but now you're doing for sorts. You're going to fill out a table and then do this, have a little writing prompt just after that. And that's what you'll submit in the Google Classroom. Okay. Anyway, let's talk about this. Okay. Sorry, I'm just. So, and this is what you should be doing right here. I'm not going to talk at all about writing code. I'm just going to talk about the math involved. And that's what I'm saying. That's what you should do when you get to the AP test, is have pencil and paper handy, and do not start trying to code first. Figure out what's going on first, and then try to code that. And so here, you're trying to format your contents into 20 spaces. You have a maximum 20 spaces, and so you're not going to get any more than that. And so obviously the 14 you just count. If there's 14 letters in 20 spaces, there's 6 spaces. You'll need to calculate that. That's easy. Number of gaps. Someone tell me, how do you find the number of gaps immediately? How are you going to calculate that from the list? If there were 100 words in the list, how many gaps would you need in your string?
99.
Exactly. So the number of gaps is just the size of the list minus 1. Easy. Okay. Now, the last 2 is where it gets interesting. So, hold on. Right. So here, we had, let me do some math here and see if this is going to work. We do 20 minus 14 is 6 spaces. And if I do 20 divided by 3, I get, no, I get 2. Divide. And right, there you go. So this one, it works out perfectly. You had 6 spaces and you had 3 gaps, and so it's 2 apiece. Let's do the next one. That was just the easy version. Here, first of all, obviously 20 take away 15 means we have 5 spaces to account for. 3 gaps again, because 4 minus 1 is 3. And so now when I do the math, it goes in once, and then the remainder is 2. So the math is easy. That's where you get in the 1 and the 2. What do you do with them? Well, your gaps will all be 1 apiece, basically. That's what the 1 signifies. But then what do I do with the 2? I add 1 to each gap, starting from the leftmost gap, as far as I can. And so, and that's basically it. So on the first one, of course, that wasn't an issue because it worked out evenly, but here, that's what you'll have to do. Then the last example, you do 20 take away 9 is 11 spaces. You only have 1 gap. If I do the math again, 11 divided by 1 is 11. 11 mod 1 is 0. So it's another really nice one. All 11 spaces went in between, and so that's as easy as it gets. Really, the second example is the one you want to focus on when you're trying to figure out how your code is going to work out. Right now, that's all I want to do is kind of get you going in the right direction in terms of the math and what the goal was. I'm not looking at any code today.